Right, here we are in Avogadro. Let's make some ethane. So here's a carbon, and then I've got adjust hydrogens selected. I'm going to click on hydrogen 4, and now I've got ethane. Let's rotate it around, and you can see that it's in the staggered conformation. Alright, rotate it around again. Let's measure that angle. Notice I have labels on so I can see what's hydrogen, what's carbon, and how they're numbered. I'm going to measure the torsional angle. Click on hydrogen 1, carbon 2, hydrogen 4. You can see my dihedral is -60. Rotate that around again. Okay, and you can see -60 degrees because it's going counterclockwise. Alright, then let's go to View, Properties, Atom Properties, and you can see how Avogadro has numbered these atoms. Atom 1 is a carbon, and attached to it are 3 hydrogens, and then atom 5 is a carbon, and attached to it are 3 hydrogens. And so it's atom 1 through 4 are this front group, and atoms 5 through 8 are the back group. And unfortunately, the labeling isn't carried over where we don't know for sure which is H1 and H2. We could probably figure it out from the Cartesian coordinates. I don't think we really have to. Okay, that's also view the torsion properties. And you can see essentially we have that -60 here is torsion 1. And here it does have H1, C1, C2, H4. Alright, anyway, now if we want to minimize the energy, we can go ahead and do that. I find this one seems to work well. And we've got an energy. No constraints so far, and I still got that 60-degree angle. Now let's go ahead and put on some constraints. So under molecular mechanics, constraints, torsion angle, and then let's say I change it to 0, but now I need to go with these numbers. So I don't remember for sure or know for sure, but I'm just going to say that atom 2 is that first hydrogen, and then atom 1 is that first carbon, atom 5 is the second carbon, and then I'll just pick one of these, we'll say 6. I'll add that constraint, hit OK. It doesn't change automatically, but if we go back in and say optimize geometry, boom, there you can see that it changes. So now I have a new energy, and this doesn't automatically update, but I can go in and view properties, torsion properties, and now you can see I'm not at exactly 0, but I'm pretty close with my torsion 1. So I have an energy as a function of angle, and I can repeat this process for a bunch of different angles and compare it to my literature values.